Hi friends, welcome to my channel. Let's have a look at problem 213, House Robber 2. So this video is a continuation of the video on House Robber problem 198. So here we would use the solution to leetcode 198 to solve the problem here. So first I'll read through the statement of this problem to look at the difference of the two problems, and then we share the simple analysis, and finally we share the code. First, we want to rob some houses to collect money, but the houses here are arranged in a circle, so that means the first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So the question again is, given an integer array nums representing the amount of money of each house, return the maximum amount of money so we can rob tonight without alerting the police. So the difference is that the head and tail are regarded as neighbors in this problem. So here in this problem, there are three examples. So in example 1, so the output is 3. So we can rob the second house. So then afterwards, we cannot rob the neighbors. So also we cannot rob 2 and 2 because the head and tail are connected. So that's example 1. So we are not going to explain the next two examples. So the constraints are actually similar. So the first one is the nums array has length bounded above by 100, and the nums is not empty. So the first constraint defines the problem size. And the second example, so here we want to point out that the nums I is not negative. So that's actually and can be important, right? Because there's no negative money. So with that said, first let's recall the solution for a non-circular array-like problem in problem 198. And in that case, or in the case of problem 198, so we use dp as below. So first, dp rob I means that the maximum money can be collected up to house I if we rob house I. So dp not rob I is the same thing, but we do not rob house I. So with this interpretation, so the dp update rule or the recursion relation can be easily obtained. So first, dp rob I. So if we rob the ith house, then the first item is the money in that house, and then we cannot rob house I-1, so we add dp not rob I-1. So for the dp not rob I, so we can rob I-1 or we can choose not, right? So that's why the maximum money will be the maximal of these two. So dp rob I-1 and dp not rob I-1. So verbosely, so we are going to return the maximal number in the two tables, dp rob and dp not rob. So that's the problem or the solution to problem 198. So here the connection of problem 198 with the problem here is the following, as in the hint. So in the hint, actually it's used y indexed. So since the head and tail are adjacent, so they cannot be robbed together. So therefore, the problem becomes to rob either house 1 to house n-1 or house 2 to house m, depending on which choice offers the more money. So that's actually the connection. So with this connection, so to solve the problem here, so we just need to consider nums, so up to before the index n-1, or leaving the head, consider nums starting from 1 to the tail. So to check which option gives more money. So that's the solution plan. So here actually it's a caution. So we need to treat special cases. So when the length of nums is 1, So in this case, we just need to collect the money in the array. So with that said, we can actually borrow the code from the previous video or solution and then write a solution here. So for that purpose, I'm going to write another method just to isolate the problem. So I'm going to call it house rob. So basically, this function will give us, if we are given a non-circular array, so what's the amount of money we can collect. Let's assume this nums is not empty, right? So then what we are going to do is that we can actually copy the previous code. Now let's go over it. First, so we are going to initialize a length. So notice that by our assumption, so this is greater than or equal to 1, right? And then first I will write a verbose Dp. So for this, I'm going to dp rob. That's going to be 0 times m, and dp not rob. That's going to be 0 times m. And then we want to make some initialization. For example, dp rob 0 will be nums 0, right? And then we're going to do the iteration. So this first for lines finishes the preparation or initialization. So next we do the dp update or iteration. So for I in range, so starting from 1 ending at n-1. So first we're going to update dp rob I. So this will going to be this is going to be nums I plus dp not rob I-1, because if we rob house I, we cannot rob the previous adjacent house. Then dp not rob I will be the max of dp rob I-1 or dp not rob I-1, because if we do not rob house I, so we can choose to rob house I-1 or not. So with that done, so we can actually give a final return that is maximal of the max dp rob and max and dp not rob. So this is a hyperfunction for this problem. So now with this function or method done, so we can easily treat this problem using the hint or the connection here. So for this purpose, first I'm going to initialize this n will going to be nums length of nums. So first I'm going to treat a special case. If n equals 1, so then we are going to return nums and 0. So because here nums contains elements that are not negative. So this is the first case. And then what we're going to do is that we call this method, consider two cases. So result 1 equals self house rob. So we're going to consider nums. So we drop the head. This is the one case. Another case is that so self house rob. So we drop the tail. So n-1. So that's the thing. So notice that so these two array or lists are not empty due to the fact that we have treated the case n equals 1. So with that said, what we are going to return is nothing but the max of result 1, result 2. So that's a full solution to this second house robber problem. So first, let's do a special case check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the test cases. So I guess for this specific problem, that's about it. So actually, so we used the code for problem 198 to solve this problem. So as in problem 198, so we can for sure optimize or improve the house rob method by using O1 space, but that's not the focus here. So for this problem, main thing is to treat the circular situation. So using this one, we consider the dropping the head and dropping the tail to avoid robbing the head and tail simultaneously. So that's about it for this video. Thank you very much. So in the follow-up video, we're going to look at the third house robber problem, which involves a binary tree. So with that said, that's about it. Thank you.